Hello everyone, my name is Prince Sharma and I am Faculty of Science and Technology and Environment and Ecology. We are here at Kuniya Institute of IAS and I am going to explain in this video about the slingshot method we use in the Chandrayaan-3. So if we talk about our lunar mission, this is the third version of the Chandrayaan, and before that we already launched about the Chandrayaan-1 and Chandrayaan-2. So which method we utilized for launching Chandrayaan-3 mission, that is the slingshot mechanism. So if we show you the diagram, this is a method we call slingshot method. So when we say slingshot method, so this method or we can say technique utilizes gravity to generate velocity required to enter the moon's orbit. So the benefit of this particular slingshot mechanism is that it requires very low amount of fuel. Now with the help of one video we will discussing about the launching of the mission, and we'll discuss about the slingshot mechanism, right? So here this is the video. Let's see here. Now what you will see, this is a GSLV, geosynchronous launch vehicle we have. Now with the help of this vehicle we launched Chandrayaan-2 mission. This is the video from the Chandrayaan-2. Okay, so now what we will observe, that the first stage is ignited. Okay, GSLV Mark 3. Now it will lift off. After that you will see, after completion of the first stage will get separated from this particular module launching vehicle. Okay, now then after that what you will observe, the second stage second stage got separated. Here you see what we are observing here. This is the payload, right? And now this second stage got removed from the launching vehicle. Now after that what you'll observe, this is the module, Chandrayaan module. Now this got separated from the launching vehicle and now it will going to enter in a elliptical orbit around the earth. Now what you are going to observe in this particular movement, there will be two important point in this orbit. One is perigee. This point is perigee, the near one about the earth, and when we say another point, that is basically apogee. So in this orbit the nearest point is perigee. This point, maximum point, we call far away point, apogee. So here we fire the engine so that we can increase the velocity, and when this orbital achieve the velocity where it can leave the influence of gravity, then it will move towards the moon. Now the moon's gravity is going to capture this module after entering into the gravity of the moon. Now what you will observe, then it will again enter in the elliptical orbit, and then what will happen, whenever it reaches the near point in this orbit, then the speed we are going to decrease about the some value. Now after that, slowly and gradually you will see it will reach in a circular orbit near the moon, and then what will happen, when it will establish itself in the circular orbit, then another important development is happening here. The lander from the orbiter getting separated, and now the lander is moving towards the landing on the surface of moon. Now what you will observe here, when these lander is going towards the surface of the moon, now deboosting process will take place. Deboosting, it means the speed will be getting reduced slowly and gradually, so that we can prevent it from the crash landing. It means our main motive is to land this particular module. We call it soft landing. Remember that, soft landing we call it. Okay, so this is deboosting process, and this is the landing of what we can say Chandrayaan mission. Now after that what you will observe, the rover will come out and try to perform the experiment. So this is what the method is all about, slingshot strategy. Now we'll again move towards this. Now you will see, again I'm repeating the things. This is the earth, and if we launch the mission with the help of GSLV, now we place we inject the module into the elliptical orbit, and when this orbiter will move, or module will move in this orbit, when it reaches up to the near point, it means what? That perigee will going to basically fire the engine and then increase the velocity, then another basically larger elliptical we can say path. And when this particular module will achieve that velocity where it can leave the influence of the gravity of the earth, then it will move towards the basically your moon, and then moon gravity going to capture this particular module, and then same method deboosting, we are going to decrease the distance, and slowly after that circular orbit, and then landing will be be successful on the surface of moon. Now what is the benefit of slingshot method? It requires time, but remember that this if we are saying this method, it basically saves the fuel a lot, and that is why our missions as compared to other space organization will see this is the we can say money saving mechanism, we can say. That is why our missions are economical in terms of money. Okay, so that is all about the slingshot method. I hope you like the video. Thank you.